All right, Department of Energy Fundamentals Handbook, Engineering Symbology, Printings and Drawings, Module 3, Electrical Diagrams and Schematics. List of figures, list of tables, reference objectives, electrical diagrams, schematics, symbology, transformers, switches, fuse breakers, relays, contactors, connectors, line resistors, miscellaneous electrical components, large components, types of electrical diagrams, reading electrical diagrams, schematic summary, and electrical wiring schematic drawings, reading and examples, and summary. A list of figures, um, basic transformers symbols, transformer polarity switches and switches symbols, switch and switch status symbols, fuse and circuit breaker symbols, three-way phase and removable breaker symbols, common electrical component symbols, electrical components, comparison electrical schematic and pictorial drawings, electrical schematic wiring drawings, diagrams of car electrical circuits, schematics of car electrical circuits, example of electrical single line, example of the relay contacts, gained switch signals, switch symbology, three-phase symbology, example 1 and 2, list of tables, comparison between wiring and schematic drawings. Reference dimension tolerance, graphic symbol, electronic diagrams, digital troubleshooting, engineering drawings, design handbook of logical circuits, logic design integrated circuits, and naval auxiliary machinery, reading schematic symbols, standards, geographical symbols, system summary, Westinghouse pressurized water reactors, valve selection handbook. Terminal objective, given an electrical print, read and interpret the facility, electrical drawings and schematics, identify the symbols of the engineering electrical drawings as following: single phase circuit breaker, open and closed, three-way circuit breaker, open and closed, thermal overload, A and B contact, time delay contact, relay, potential transformer, current transformer, single phase transformer, delta wound transformer, wire wound transformer, electrical motor, meters, junctions, inline fuses, single switch, multiple position switches, push button switches, limit switches, turbine driven generators, motor generators, set generator Y and delta belt division diesel driven generator battery. 1, 2. Given electrical drawing and circuit containing the transformer to determine the direction of the current flow shown is by the transformer. The symbol, identify the symbols, codes, and the use of energy electronical drawings depicted with the relationship between the following components: relay and contact, switch contacts, and interlocking devices, interlocked equipment. All right, enabling objects. 1, 4. State the condition in which electrical devices are shown, unless otherwise noted on the diagram schematic. Given a simple electro-schematic initial conditions, determine the condition of the specified component: energize, de-energize, open or close. Give a simple electrical schematic initial conditions, identify the power source on the loads and their status: energize or de-energize. Electrical diagram schematics. This is again with the questions. Symbology. To read and interpret electrical diagram schematic, the reader must first well be versed in what many symbols represent. This character discusses the common symbol used to depict many components with electrical systems. Only mastered knowledge should enable the reader to successfully understand the electrical diagrams of schematics. The information flows provided with the details. Basic symbology represents the components of electrical transmission, switching, and controlling and protection of the schematics. Shows the figure A shows a single phase and taped. Basic transformer is shows these little humps, like we'll just call them windings. All right, like the windings without anything through it. Without anything, is a single phase with a half marker, and one of them is a taped single phase adjustable one is a shows a ray through the single phase transformer. Your iron core shows a phase the windings the current windings instead of an X or zigzag, they're humps. So a hump with two parallel lines through it means an iron core, and if you see three of them in a row, that means it's a three-way phase. Figure 3 shows a three-way phase Y ungrounded, which is three connection points on three wires with three little hump windings, currents, and three-way delta phase is a triangle that's not from the center of the triangle, but on the outside points. And your ways is grounded, shows a ground signal with it, which is a line in like a triangular dash pyramid. Your potential for your potential is a small single phase with straight through the line on a connected line. The current shows a current is a M through the line. or a transformer side single on the current. The basic symbol of the various transformers are shown in Figure A, Figure 1A, and 1B. It shows how the basic symbol of the transformer modified to represent the specific type of the transformer application. In addition, transformer symbols are polarity marks that sometimes indicate the current flow of the circuit. The information can be used to determine whether the phase or relationship between the input and output terminals of the transformer. These marks usually appear to the dots in the transformer symbology shown in Figure 2. The primary and secondary example of 1 and primary 2 show the transformer polarity going through and from the top side and from the different connection points in the transformer. On the primary side of the transformer, the dot indicates the current, or the secondary side of the dot is secondary side on the dot and current out. The given instant with the current flowing through the transformer, the dotted end of the primary with the coil with the flowing out of the transformer, dotted end of the secondary coil with the current flow of the transformer using a dotted symbology and illustrating Figure 2. Our Figure 3 shows the most common type of the switches. The symbol of their pole and used in describing the switch in Figure 3 to refer to the normal points of the which for the current send enter the switch. The single pole and double pole switches are shown, but switch may have the many poles and required to perform the function. The term throw used in Figure 3 refers to the number of circuits that each pole of the switch can completely control. All right, Figure 1 is a single pole switch is aligned with like a door opening if you were to close to the architectural without the curvature swing. And double pole would be a double swing relay or a single pole with a line through it. A single pole double throw switch is in between two contactors, two line contactors, which throws one off and one on. And double throw is a two lines on a double throw on one single switch. Push button normally operated, two connection points with a perpendicular line on it. Two connection points with connections on it is a normally closed push button. Positions, two position, NCO, and normal open, normal closed, double pushing perpendicular connection line with the connectors dying on a lot of it. Multiple position switch is a curve of dots on it with points, and the relay on an arrowhead switch. Figure 4 provides the common symbol used to denote the automatic switch examples of how the symbol indicates switch and actuation limits. The arrowhead goes to switch between the connection points, and this shows the normal open, hold, closed, normal closed, and closed, hold, open. The open switch is shown by a time delay closing or marked TDY, which has a Y on the actual signal switch, and if it's not marked with the abbreviation on the single phase pole switch, it's either an arrow or a Y for the delay close open or delays close flow actuated switch is a arrow-headed arrow flag off of a switch, a flag on a connected switch and open increase inflow. Liquid flow actuated switch closing a rising level open switch. Ocean bulb switch, open rising level, open closed bulb switch. Pressure vacuum actuated is a half circle or a semicircle on a pole on an open switch. Open rising pressure is a closed single switch with an open half a circle. Temperature actuated switch closing on a rising temperature is a bitted section or is marked IEC with a bitted relay or a bitted close or bitted open relay. Alright, Figure 5 depicts the basic fuse and circuit breaker symbols, signal phases, application in addition with the graphic symbols. Most drawings will also provide the rating of the fuse next to the symbol. The rating is usually in amps. Alright, this shows a plug fuse, ribbon fuse, knife fuse. The shows the different a circuit breaker with a rectangle with two different small and figures on the other end is a fuse, and a swerve line also represents a fuse. Or like if you have a thermal type circuit breaker, it's a convex line over like as a relay for the switch showing the open, and then a bit or a double semicircle on a convex relay. Or you can have the magnet type circuit breaker, which is a convex relay on a heart rate magnetic device signal. Shows the magnetic device signal. The fuse breakers and switches are used in the three-way system. The three-way system symbols combine single phase symbols and triplicate them. So if you have a three-phase, you're triplicating your symbols. In Figure 6 is symbols removable breaker, which is the standard breaker. Symbols placed in between the set of chevrons. A chevron represents a point in which the breaker disconnects the circuit and removed. So actually, those weren't relays, but they look like relays. But they're a gap between these breakers, and a breaker basically a fuse. So you have your convex breakers on a triplicated. This is the three-phase breaker, and a three-ways removable breaker. The arrows go face double arrows facing in, also replicating the three-phase breaker symbol. Relays, connectors, liners, resistance, miscellaneous electric components shown on the common symbol. Relays, contacts, connectors, line resistors, and other miscellaneous electronic components. All right. Figure 7 shows the common electrical points. A circle and a circle with a line on the outside going through it without the center line through the circle, or a heart rate is a basic relay. A relay with mechanical connection shows a circle without the line going through it with a dotted line off the perpendicular with it. A base contact is a teed in between a parallel lines in between a straight line or a connection point with an arrow headed toward the line. A type of the contact removable shows the B type of the contact, a breaker with a parallel and basic contact with a line through it, or a connection line with an arrow facing pointed onto it, one arrow pointed onto it with a filled-in marker. Transfer contacts are a double one type basic contactor, one type breaker contactor on a circuit, or a double arrow headed pointed to the line linear point on a connection line. The two time delays are marked TDC or TDO for time delay open, time delay close. Parallel lines, one with a cross through it, also the type of breaker or basic contact. Sequential contacts are done like is on a perpendicular line with raised tees different degrees away from it. Connectors, female is a end of an arrowhead, male is the front of an arrowhead, and separable connectors are engaged with a double arrowhead inside the line. Conductive path is a straight line. Two conductive paths is a double straight line or a line with two lines through it. Three conductor paths is a line with three lines or a line with three lines through it. A path crossing is either a perpendicular line or a perpendicular line jumping the wire or a missed dot. Path connection is done by a dot on the line on the path, holding the line on both lines of filled-in dot. A resistor is a regular diagonal line, or a tape resistor is a regular diagonal line with two lines with like parallel lines spanning slightly off the edge of the trough and the pitch of the resistor. The thermostat is a perpendicular arrow-headed line, filled arrowhead line touching the middle of the resistor. The panometer is a needle is a small indication mark on a panometer and a resistor. Circuit ground relay is a perpendicular with a triangular pyramid lined. Capacitor is a flat T versus a convex T. Touching each other, chassis ground, three wires to one. Inductor is what looks to be like a light bulb light up, which is probably pretty close to amplitude. Is a curled loop-de-loop inductor, or a thermocoupler is a humped line. Or the inductor is either a loop-de-loop or a straight line, or the thermoconductor is two angled lines connecting in a connector. Lamp shows the what looks to be like a lamp bulb or a circle with a cross on the outside of it without the middle into it, like four connectors. Voltmeter is measured with a circle as a basic relay with a V. An ammeter is basically a relay with an A. Ohmmeter is a basic relay with an OHM. Large component symbols of figure 8 are used to identify large components. They must be found in electrical drawings and may be found in electrical drawings and schematics. The details for these symbols will vary when used in system diagrams using automatic detail to reflect the relatively important components of the particular diagram. Alright, a motor is either measured with a circle with an M or a G for a generator, or the small abbreviation. Single phase motor is a circle with one cord on it on the side. Two double phase is double cord. Three phase is a central pi marked at 3 degrees. Three at a third of dimension pi with a ground symbol off it. Third way Y grounding. Alternative Y grounding facility outside the from before with a or a current current hump to hump with Ys or Ys on the ends, ungrounding. Three ways ungrounded shows a three-dimensional pi or a circle without a three-way Y. Then it shows you the transformers with the Ys in it, two halves, one circle Y resistors. Three-phase delta is a triangle or alternative three-ways delta, three-phase delta outside of circle, or the transformer drawing with triangles at the bottom of the end. Turbine-driven engine, a triangle slash marked at the generator through to a line, like a triangle to a generator with a connector to a generator, a circle, or a TG for turbine generator, driven generator. A square to a circle on the outside is either or a DG shows the driven generator. A motor in a generator is circled in plus equal, circle next to a generator. Single cell batteries are plus and a minus, and then multiple cells shows different dividing smaller dividing lines in between parallel lines. Our type of electrical drawings and schematic. The three ways of showing electrical circuits: the wiring schematic and pictorial diagram. The two most commonly used the wiregram schematic drawings. These are the use of the two types of the diagrams are compared in Table 1. Alright, comparison between wiring and schematic drawings. Wiring drawings that emphasize connection between the elements and circuit system. They use horizontal vertical lines to represent the wires. Use simplified pictorials clearly resemble circuit and simple system components. Place the equipment in wiring and drawing approximately actually physical location of the real circuit. Schematic drawings that emphasize the flow of system. Use horizontal vertical lines to show the system of flow. Use symbols to indicate the function of the equipment. And by the symbols do not look like actual equipment. Drawing layout is done to show the flow of the system of the functions, not physical layout of the equipment. Alright, a pictorial diagram used not found in engineering applications for the reason shown in the following example. The figure 9 provides a simple example of how the schematic drawing compares the pictorial equivalent pictorial equivalent as can be seen in the pictorial version is nearly as useful as schematic, especially if they were trying to obtain enough information to repair a circuit and determine how they operates. Alright, this shows plugs in different lamps, and then this shows a pictorial of the lamps on a circuit. Figure 10 provides example of the relation between the schematic drawings. Figure 10 and figure wiring diagram. Figure 10b for the air drying unit. More complex example of the electrical circuit of the automobile is shown in the wire diagram. Figure 11. In a schematic format in Figure 12, notice of the wiring drawings in Figure 11 and the use of both pictorial representation schematic symbols. The schematic figure in 12 drops all pictorial representation and depicts electrical symbols only. Alright, white is W, orange is O, black and white is B and W, and red is white RW. So it shows the in between two lines of current, there is a thermostat and heat selector switch with motor and a relay switch with it has a bit in the bits. In Figure B, you see a red and white and a black and white going into a what looks as a heater. And also a thermostat motor with different wires. Figure 11 is a wire diagram. The dome light, the plain light, the gas unit, the fuse, the light switch, the tail stop, the beam light, the stop light switch, the horn button, the ammeter, fuel gauge, ignition switch, battery starter, breaker, ignition coil, distributor, junction box, sealed bill, horn, sealed beam, parking lamp, current voltage regulator, battery and generator, fuel foot selector switch. Figure 12 shows a schematic of a car: electricity, amper, starter switch, horn, relay, starter motor, horn, contact relays, door switch, brake switch, stop, dome lights, push horn, plate lights, parking lights, instrument, tail lights, instrument, low beam indicator with a high beam, foot switch, levers, light switch, fuse, ignition switch, coil, condenser, distributor, spark plugs, brake points, tank unit, voltage regulator, alternator, fuel gauge, transformer. When dealing with large power distribution systems, a special type of schematic drawing is called an electrical single line. It is used to show all the parts and power part of the system. The type of the diagram depicts the major power sources, brake loads, and protective devices, thereby providing a useful overall view of the flow of the large electrical power distribution system. On a power distribution signal line, even if it was three-phase system, each load is commonly represented on a simple circuit which describes the load and power rating of the running power consumption. Unless otherwise stated, the common units for the kilowatts in Figure 13 shows the proportional electrical distribution in a nuclear power plant. Alright, this shows the electrical distribution of power plant. You see the Example of electrical single line drawing. Reading electrical diagrams and schematics. To read electrical schematics, system diagrams, schematic property condition of the state, each of the components must be fit or is understood. The for electrical schematic, the details involved individual relays, contact components also shown in de-energized condition, so also a shelf stated to associate proper relay with the contact that operates each of the relay assigned with a specific number and letter combination. The number of the letter code for each of the relay is carried by all the associated contacts. Figure 14A shows a simple schematic contained with the coil or M1 is its contact. The space permits the relationship may be emphasized, but the drawing dash line symbolizes the mechanical connection between the relay and contact. The dash box around shown in Figure 14B and Figure 14C illustrates the switch and second set of the contacts operated by the switch. Figure 14 shows a graphic method of indicating relay contact. This is the differential for Figure B, and Figure C shows the graphic method of indicating switch contact relationship. It starts with a circuit breaker on a fuse with a circuit breakers on the outside of the fuses. There was also a line going. The first line goes into on both sides. There's two fuses with a relay that runs to the circuit breaker. But from the circuit breakers, there's a 240 volt source which runs from the transformer iron core from the 120 volt pilot circuit, also to another circuit, but also reaches overloads and a relay. And a holding contact start switch and stop switch in a loop. Also, from the original bottom side of the line, from the before the relay fuses, there's a heater contact, motor heater, and there's two heater contacts and a motor. And that is the example 14. When a switch is used in the circuit, it must be contain several sets of the contacts. The small switches, internal switches are shown individually in the schematic. In many cases, the position of one internal switch will affect the other position in others. Such switches are called gang switches, symbolized by the connection of the dash line, and shown in the Figure 15A. The example closes switching 1 and closes switching 2. The dash line also indicates the mechanical interlock between two circuit components. Figure 15B shows two breaker interlockers between. Figure A shows a gang breaker switch, and the different operations 1 or 2 is in swing convex or single line finish switch with basically one double throw switch, but they're gang switches, so one affects the other, and a mechanically interlocking 1 and 2 switches. This also shows an interlock switch in Figure B. In single system line diagrams, transformers only represented by the symbol single phase air core transformer. However, this does not necessarily mean the transformer has an air core. That is single phase single line system diagrams instead of convoying on only the general function information similar to the type of the information represented in piping instrument drawing for the piping system. The reader must investigate further if more detailed diagrams depicted. Picking three-phase system, a small symbol must be placed into the side of the transformer, primary, secondary, indicating the two types of transformer winding and or that are used. The Figure 16 shows the most commonly used symbols to indicate how the fuses are connected. Three-phase winding. Figure 16 illustrates the example of how the symbols appear in three-ways winding. All right, you have a split as three ways and three-way Y. A three-way Y with a grounding symbol. A triangle is where it shows an ungrounded delta. A triangle with a grounded delta. Also, Figure B shows a transformer with a delta sign on it, and a Y signal or a double delta transformer signal. Summary. The most important information in this chapter is summarized below. The electrical diagram schematic summary. The chapter covered the common signals. Electrical diagram schematic represents the basic electrical components. Polarity of the transfer defined in the dots placed on the primary and secondary winding. The primary side and the dotting indicate with the coordinate within, and the secondary does not include the current. Switch and relay interlocked equipment commonly use the dash line box indicating the relationship between them and other components. Electrical components such as relays are drawn with the de-energized state unless otherwise denoted on the diagram. Alright, electrical wiring and schematic reading examples. This is the figures. These are the pictures. I was wondering if there's any more of this chapter to go. I will probably split these up together and post these in my OneNote class. Thanks for listening. This has been a Department of Energy Fundamental Handbook Engineering Symbols, Prints and Drawings, Volume 1 and 2.